In this lesson, we're going to solve linear equations. This should be a review from Algebra 1, but it escalates quickly. We will review some basic equations, but then they tend to get more complicated very quickly. So just try to follow along and let me know if you have any questions. The most basic of all equations are those where the variable, say x, is only raised to the first power. These are called linear equations. As we move through Algebra 2, we're going to see all different types of equations, and you need to know them by how they look and by how they look after you graph them. You need to be able to easily solve linear equations. Steps to solve linear equations. You're going to simplify the left side, then the right side of the equation. It says use PEMDAS in reverse order. I think that kind of happens naturally, but really you want to move everything away from x using the opposite operation. So in part A, I have 3x plus 5 equals 26. So I want to move the 3 and the 5 away from that x. So I'm going to subtract the 5 first from both sides. And when I do that, I get 3x equals 21. And then the next thing I'm going to do is divide both sides by 3. And x equals 7. I don't require you to do checks, but if you're not sure, you definitely should substitute that 7 back in and see if you get 26. In part B, you have x on both sides, and that's a bit of a problem. So the first thing you want to do is see if you can simplify or combine anything on the left side, which you can't, or anything on the right side, which you can't. So what I'm going to do instead now is I'm going to combine the x's. So I'm going to subtract the 4x from both sides. So it'll cancel on the right, and I'll have it just left on the left side. So 4x minus 7 equals, now this is a negative 5. Be careful there. Don't lose that negative in front because you didn't touch that before. Now this looks like, we call it a two-step equation just because it takes 2 steps to solve it from here. It looks very similar to what we just did in part A. So I'm going to add 7 to both sides, and I get 4x equals a positive 2. Be careful with your negatives there. And now I'm going to divide both sides by 4. Now 4 does not go into 2 evenly, but if you divide it, you get 0.5, which is fine. Or you could reduce it to 1/2. 1/2 and 0.5 are exactly the same. Either one's acceptable. This is Algebra 2, so you are going to get answers that are decimals and fractions. So if you get that, don't think that you did anything wrong. Okay, part C. I kind of stretched the page out because I know this is going to take a lot of space. You might want to do this on lined paper because I don't think there's enough on your paper, but okay, so C is a little bit more complicated because now we have a fraction. I usually try to get rid of the fraction right away, but in this particular case, it actually makes a little bit more sense to isolate the fraction first. It's actually less work overall. So I'm going to subtract the 7 from both sides, and they're going to cancel here. So I get 6x plus 10 over 2 and x minus 11. Now that my fraction's isolated, I'm going to get rid of it. So I'm going to multiply it by 2, and what happens is these cancel, and so now it's gone. But whatever you do to one side, you must do to the other. And both terms on the right side have to be multiplied by 2. The most common mistake is we forget to multiply it by that second term. So that gives me 6x plus 10 equals 2x minus 22. And now it's looking very similar to how part B started. So I'm going to subtract 2x from both sides, and that's going to give me 4x. And that's a negative 22. Subtract 10 from both sides. 4x equals negative 32. That loud clicking, I apologize. It's this pen that I'm using. It's new, and I didn't realize it was going to be so loud. So the next thing I'm going to do is divide both sides by 4. X equals negative 8. Okay, part D is getting more complicated. It looks similar to the one before, but on the right side, I have to distribute. So I'm going to distribute that 5 first. So it's going to give me a negative 5x minus 5. And, you know, it's up to you, but I like to do all my distributing at once. So I am going to distribute over here too. So that's going to give me 3x plus 6 over 2 minus 1. Now, I'm going to add 1 to both sides, just like I did before. So that's going to give me 3x plus 6 over 2 equals negative 5x minus 4. Now, to be consistent, I'm going to multiply both sides by 2. You could actually divide the 2 into the 3x and get 3 over 2x and then divide it into the 6. That does work, but I'm just going to do it this way just to be consistent. Okay, so that's going to give me 3x plus 6, and remember the 2 needs to get distributed. So that's going to give me a negative 10x minus 8. I'm going to add 10x, add 10x. Okay. Now I'm going to subtract 6 from both sides. 13x equals negative 14. Don't panic if you're realizing that the 13 is not going to go into the 14. That is okay. You can turn it into a decimal, but if it's a long decimal and you end up having to round it, you can actually just leave it as a fraction because technically that is more accurate. All right, part E. It's a little bit longer. There's no fraction, which is nice, but I do see some distributing that needs to happen. So I'm going to distribute the 6. So that's going to give me 6x plus 24. And here I'm going to distribute a negative 2. You need the sign in front there. So that's going to give me a negative 2x plus 2. If you don't distribute that negative, you're going to end up with a negative 2 here, and then it is going to mess everything up. Now on the left side, I have x's in a few spots. So I'm going to combine the 6x minus 2x, which gives me 4x. And the 24 and the 2 are constants. I did mention that the other day in class. So that's going to give me 26 because they're both positive. And then on the right side, there's nothing that I can combine together. But now I can move my x to the left side. I usually move it to the left because I like my x to be on the left side. Some people like to move the smaller one over. So that's going to give me 2x plus 26 equals 20. I'm going to subtract 26 from both sides. So I have 2x equals negative 26. Divide by 2. X equals negative 13. Strange things can sometimes happen when solving equations. Sometimes we get no solutions at all, in which case the equation is known as inconsistent. This word is a little weird, this inconsistent word. What you would have heard before, or what might sound familiar to you, would be no solution, right? But they're using inconsistent here. And then, so that's when you end up with, you're solving it and you end up with 8 equals 5, which is impossible, something like that, which means there is no value of x that would ever make the equation true. And then the opposite of that, other times when any value of x will solve the equation, in which case it is known as an identity. So what they're saying here is any value of x will make it true. And when that happens, sometimes you don't even have to solve the whole equation. You'll recognize it earlier on, all right? So in exercise 2, they want us to solve it and then state whether it's an identity or inconsistent. So I'm going to distribute my -2 first. And that's going to give me a -2x minus 8. And I'm going to bring this 6x down here. And I'm going to distribute that 3 there. It's going to give me 3x plus 6. And bring down the rest. On my left side, I'm going to combine my like terms, and I'm going to get 4x minus 8. And on my right side, I get 4x plus 1. Now, you might recognize it right here, and you can stop. If you have 4x equals 4x, well, they're going to cancel each other out, and you're going to end up with -8 equals 1. Well, that can never happen. So you could stop here, and you could say inconsistent. I like to do, this no solution, but you can say inconsistent. But if I wanted to continue showing my work, I would subtract 4x from both sides, and I would get -8 equals 1, which is not true. And so that's where the inconsistent comes from. All right, so on the next page, exercise 3 says an identity is an equation that is true for all values of the variable, meaning any x you plug in, the equation is still going to work. Trying to solve them can lead to confusing situations. Consider this equation. So they want us to test the values of 5 and 3 to see that they're both solutions. I'm going to save time. I'm going to do it for you, and I'm going to show you what it looks like. So this is what it looks like when I plug in a 5 for all the x's. If I quickly evaluate the left side, it gives me 8. And then if I evaluate the right side, it gives me 8. So that says that x equals 5 is a solution. But they also want me to do the same thing for 3. So I'm going to plug that in and solve it as well. So this is what it looks like when I plug in a 3. It's the same thing, except now I have a 3 wherever the x's are. And when I evaluate the left side, that's going to give me 2. And when I evaluate the right side, that also gives me 2. So when I plug in a 3, the two sides are equal. So 3 is also a solution. So what they want me to do for the next part, or you to do really, is to actually attempt to solve the equation and then show that way that it's an identity. So on the left side, I'm going to combine. I'm going to do 2x plus x. So that gives me 3x. And then I'm going to do -6 minus 1, which is -7. On the right side, I'm going to distribute the 3. So that gives me 3x minus 9 plus 2. So I can combine my like terms on that side, and that gives me the same thing. So I have 3x minus 7 equals 3x minus 7. So that is an identity. And you can also use the infinity symbol, which I'm terrible at drawing. Exercise 4 says which of the following equations are identities, which are inconsistent, and which are neither. Neither means that it has an answer. So if you start to solve it and you get x equals a number, it's solvable. And so it's not an identity or inconsistent. So what I want you to do right now is to work on these. I'll slowly put up the answers. I'm not going to show the work. I'm just going to tell you if it's an identity, inconsistent, and neither. And then when we gather back together as a class, we'll go over whichever ones you would like to go over. All right, so that's it for this lesson. We're going to come back together as a group live, and we'll go over any of these that you want to go over. See you there.